This video is about applying the properties of a trapezoid and an isosceles trapezoid. So a trapezoid is different than the parallelogram, rectangle, rhombus, and square because a trapezoid is quadrilateral with only one pair of parallel sides. So the base is going to be the two parallel sides of our trapezoid. So we always have two bases. So we have a base here and a base here. The legs then are going to be our two non-parallel sides. So we have a leg and a leg. And then our base angles are angles that are formed by a base and a leg. And in a trapezoid, we have four of them. So we have 1, 2, 3, and 4. All of these are our base angles. So a trapezoid has two different properties. One, the bases of a trapezoid are parallel, and two, the consecutive angles that are one angle from each base are supplementary. So in this case, we would have the measure of angle 1 plus the measure of angle 2 is equal to 180, or the measure of angle 3 plus the measure of angle 4 is equal to 180. The angles that are touching the same base have no relationship with each other. They have to be touching two different bases. So let's use this property to solve for x and y. So number one is solve for x and y. A and G are touching different bases, so they're going to be supplementary, so we're going to add those together. So 5x plus 13 plus 3x plus 15 equals 180. So to solve for x, our first step is to combine like terms. So we get 8x plus 28 equals 180. Subtract 28 from both sides, and we get 152 equals 8x. And when we divide by 8, we get x is 19. To solve for y, we're in the same case here. B and C are supplementary because they're one angle from each base. So we have 103 plus 10y minus 3 equals 180. So we combine like terms. 100 minus 103 minus 3 gets us 100. So 10y plus 100 equals 180. We can subtract 100 from both sides. So 10y equals 80. And when we divide, y equals 8. So in number 2, we're going to use the same idea. So D and G are supplementary. 3x plus 9y plus 90 equals 180. So notice that there's an x and a y in this equation. So I'm going to move 90 to the other side. So I have 3x plus 9y equals 90. So that's one equation. The other equation, I have 114 plus 5x plus 3y equals 180. And when I subtract 114 from both sides, I get 5x plus 3y equals 66. So now that I have two equations, I can use those equations to solve a system. So I have 3x plus 9y equals 90, and 5x plus 3y equals 66. So in order to eliminate one of my variables, I'm going to multiply the second equation by -3. So I get 3x plus 9y equals 90, and -15x minus 9y equals -198. So when I add straight down, my y's cancel out. I'm left with -12x equals -108. And when I divide by -12, I get x equals 9. Now, once I know x is 9, I need to go back and get y still. So I'm going to do 3 times 9 plus 9y equals 90. 3 times 9 is 27. And I can subtract that from both sides. So 9y equals 63. Y is 7. So my ordered pair would be 7, 9. Or sorry, 9, 7. So an isosceles trapezoid gives us a few more properties. So an isosceles trapezoid is like a isosceles triangle. So in an isosceles trapezoid, the non-parallel sides are congruent. So in this case then, BC and AD are the non-parallel sides, so those are congruent. So in an isosceles trapezoid, we have the properties we just talked about. We have that the legs of the isosceles trapezoid, so AD and BC, are congruent. Then each pair of base angles, so just like in a isosceles triangle when the base angles were congruent, the base angles that touch the same base in an isosceles trapezoid are going to be congruent. And then our last property is that the entire length of the diagonal, so BD and AC, are going to be congruent to each other. So let's use these properties to solve for a variable. So number 3, find the missing angles. So we know we have our parallel sides, which are our bases. So B is congruent to A, and C is congruent to D. So right away we know that C is 100. Then to get B and C, remember that those are supplementary to each other, and A and D are supplementary to each other. So to get those missing angles, we're going to do 180 minus 100, and we get 80. So B and A have measurements of 80 degrees. Number 4, solve for x and then find all the angle measures. So this is an isosceles trapezoid because M and MP and NO are marked congruent, which means my base angles are congruent. So M is congruent to N and P is congruent to O. So to solve for x, I could use supplementary with M and P, or because I know it's isosceles, I can just set the base angles congruent. So 6x plus 6 equals 5x plus 18. We can subtract 5x from both sides, and then subtract 6 from both sides, so we get x is 12. Once we know x is 12, we can substitute in. So 10 times 12 minus 18 gets us 102, which means that n is also 102. And 6 times 12 plus 6 is 78. So O is also 78 degrees. Number 5, AC, so the entire length of A to C is x squared plus 5x. BD is 2x plus 18. And then our legs, which are AB, is 7y minus 2. And CD is 26. So to solve for x, we know that our diagonals are congruent. So we would have x squared plus 5x is equal to 2x plus 18. And we know this is true because A, B, C, D is isosceles. So it also means these legs are congruent. So I'm going to get everything to the x squared side. X squared plus 3x minus 18 equals 0. So I need two numbers that multiply to 18, negative 18 to add to 3. So I have x plus 6 and x minus 3. When I switch those signs, I get x is negative 6 and x is 3. Both of these numbers, when plugged in, will get us a positive. So both answers are working for x. Then for y, because my legs are congruent, we have 7y minus 2 equals 26. We're going to add 2 to both sides, so 7y equals 28. When we divide, y is 4. So the last new thing for this video is the mid-segment of a trapezoid. So a mid-segment of a trapezoid is a segment whose endpoints are the midpoints of the legs. So y is a midpoint which splits CD into two congruent parts. X is a midpoint which splits A and B into two congruent parts. The mid-segment of a trapezoid is also always parallel to each base. So B, C, X, Y, and AD are all parallel to each other. The relationship between the length of the midsegment of a trapezoid is half the sum of the bases. So in order to find our midsegment, we're going to say that xy times 2 is equal to our base plus our base. So instead of cutting it in half and having to deal with a fraction, we're going to multiply our midsegment by 2 instead. So let's solve for x and y. So in number 6, remember that a midsegment splits the legs into two congruent parts. So y has a value of 7. To solve for x, our midsegment is 2x plus 6. So we're going to do 2 times 2x plus 6 equals, and we're going to add the bases together. So we get 4x plus 12 equals 44. We're going to subtract 12 from both sides, so 4x equals 32, and divide, we get x is 8. In number 7, our mid-segment also splits our legs into two congruent parts, so y is 10. And to solve for x, our mid-segment is 25, so 2 times 25 equals our base plus our base. So I get 50 equals, I'm going to combine like terms, 20 plus x. So I can subtract 20 from both sides, and x equals 30. In number 8, remember that a mid-segment triangle splits our leg, or a mid-segment of a trapezoid splits our leg into two congruent parts. So to solve for y, these are congruent, 2y minus 4 and 12. So 2y minus 4 equals 12. I'm going to add 4 to both sides, so 2y equals 16. Divide, so y is 8. Then to solve for x, my mid-segment is 4x plus 10, so 2 times 4x plus 10 equals 3x plus 8 plus 6x. So when I combine like terms, I get 8x plus 20 for distributing equals 9x plus 8. So I can subtract 8x from both sides and get x 20 equals x plus 8. Subtract 8, I get x is 12.